Now we will discuss about the derivative of the following function which was not discussed by us in the exercise 7.1. See this one, it is tangent x. Tangent x is equals to sine upon cos with dx. Sine having a derivative cos and cos having a derivative sine. So it is not possible for us to judge which is the particular derivative. But remember one thing, whenever you go for substitution, your dx can never become in denominator. It always remains in numerator. So dx contain the function sin x, and sin x is the derivative of cos x. So let us substitute cos x is equals to t. Then derivative of cos minus sin x dx is equals to dt. Now sin x dx is equals to minus of dt. Replace this value sin x dx with the help of minus of dt with t. Integration minus of log t plus c, constant of integration. But remember, in case of log, you always substitute the result in mode. So log of cos x, its one result will be more. Now this minus 1 will be transferred to the power. It will become cos to power minus 1. Remember that it is not cos inverse, it is cos power minus 1. So it can be written as 1 upon cos, and 1 upon cos is equals to secant. So tangent x having two integration, one is called as the log of secant x and second is called as the log of cos x with negative. Now let us see one more, cot x. Cot x can be written as cos upon sine. Again the same, dx with the cos x. So cos x is the derivative of sine x. So go for the substitution with sine x. Sin x is equals to t. Cos x into dx is equals to dt. So it will become dt upon t. Integration, again it is log t. It is log of t. T is what? It is sin x. So it is log of sin x plus c. Let us see one more. Integration of secant x. Secant x is a single function. If we replace, it will become 1 upon cos. And in case of 1 upon cos, no derivative is available. So let us try by the method of adjustment. So what we do, we go for multiplication and division with the secant x and tangent x. Secant x plus tangent x, secant x plus tangent x. Now let us substitute secant x plus tangent x is equals to t. Then derivative, secant x into tangent x plus tangent derivative secant square x into dx. From this secant x will be common. After that what is left? Secant x plus tangent x. If you see this complete function, secant x into secant x plus tangent x dx, it is the same as it is the numerator of this question now. Now substitute, it is dt upon t. Integration log t plus c. Log of t, what is the t? That is equals to secant x plus tangent x, constant of integration. Last one, cosecant. Again in case of cosecant, it is 1 upon sine, but it is not possible to find out the integration of 1 upon sine. So we go for the adjustment. Again cosec minus cot and cosec minus cot. Multiply and divide by cosec minus cot. Now again we go for the substitution. Cosec minus cot x is equals to t. Its derivative minus cosec x into cot x. Derivative of cot minus cos x square. So minus minus plus into dx is equals to dt. Again cosec x common. What is left? Cosec x minus cot x into dx. If you observe this result after derivative and this result, they are the exactly same. So replace it. It is dt upon t. Again it is equals to log of t plus c. It is log of cosec minus cot plus c. These are the integration of cosec minus cot. Now you know about the integration of each term in 7.1 exercise as well as in the 7.2 exercise. In case of 7.1 we know about the journal integration, and in case of 7.2 exercise we find the integration with the help of substitution. In exercise 7.1 there are the few terms whose integrations are not known to us, but now we know about the integration of those function also which was not involved in the exercise 7.1. So first one is the tangent x, whose integration is minus of log of cos x or log of secant x. You can use any one. Integration of cot x, that is log of sin x. Integration of secant x, that is log of secant x plus tangent x. And integration of cosecant x, log of cosecant x minus cot x. So these are the important integrations.